How to define the speed of frequency?
Well, period is, well, what is the definition of a period? Like, instead of the formula of it. So seconds. How many times does it go up and down like per second? That's inside of like transverse graph, right? But for this, how will we calculate that? We already know the wavelength, right? Can we find a way to calculate the frequency of it?
How many times it goes here?
Let's see, how about, I'll give you a hint. You're gonna, my idea for this would be to pick a point on the ruler, right? Start the timer, count how many
movements?
inside of that time.
Instead of 1 second.
Well, 1 second is gonna be quite long on that. So you could do like maybe like 0.0, like 10 seconds or something. You know what I mean?
Yeah.
That's how many are going over the frequency.
Oh yeah.
Okay? Go and try that. Because you guys' average velocity is really good already for the previous part, so it should come out to be about that as well. Okay? Go and try it. You guys have your attention?
That's what we're doing.
Okay? So we're not going to be able to finish the whole lab today. As you guys noticed, it's pretty long. So we're just going to go over the first part together. Have you guys found the average speed of sound for the first part using distance times divided by time? Let's see a show of hands. Alright, so we're gonna just, review together and see what we all got, okay? Because we got to work in our group, not all together. So, who wants to answer 1A for me? Who wants to read 1A for me?
Question?
Yeah, read the question.
Observe the sound waves coming from the speaker. What do the dark and light bands represent? Think about longitudinal waves.
Alright, who wants to answer this question? I know a lot of you got it, so I don't want to have to pick and choose people.
The dark bands represent the compression and the light bands represent the replication.
Does everyone agree with that?
Yeah.
Let's see show of hands. If you guys agree? Then how come no one wanted to volunteer? Okay, so what about part B? Why do the waves get lighter with distance from the speaker? Come on, what'd you get?
The air molecules are decompressing as they go farther away.
Right? So does everyone agree with that? Does everyone hear her?
Yeah.
Everyone here?
Yes.
Okay, anyone over here hear her? What did she say? Can you repeat yourself for us again? A little louder.
The air molecules are decompressing as they go farther away.
Right? Did you guys hear that? A little energy today, huh? Did you guys eat lunch today?
No.
Okay, so she said that air molecules are decompressing as they get further away. Because just think about like a real life example, right? I'm sure they can hear me better if I'm like right over here, right? But you guys can't hear me as well over there because you guys are further away, right? So when you're further away from the source of the sound, what happens? It's harder to hear, right? Because, obviously it gets quieter as you're further away. Like Mr. Martin's example earlier of like a football field. If we were both at the other ends of the football field, I would have to yell for you to hear me, right? Or else you wouldn't hear anything at all because it just like dies off, right? About part C, how does changing the frequency and amplitude affect the depiction of the sound waves in the simulator? All right, talk with your group for 30 seconds. And I will pick somebody. How does it affect the sound?
It makes the pitch higher. Is that a good answer?
Discuss with your group. Discuss with your group.
Increases the sound while the athlete changes the pitch of the sound.
Loki, you heard me, bro.
All right. I want to see some volunteers right now.
I got it.
All right. What do you have?
The widget, okay, there we go. It changes the pitch.
Change the pitch. How does it change the pitch?
And makes it higher.
What makes the pitch higher? Can you give me a little bit more of that? How do we change the frequency?
It causes more compression.
Well, how does that affect the sound? Like, anyone want to help her out?
A higher pitch.
What about high pitch?
It causes a higher pitch if you increase the frequency.
Everyone hear that?
Yeah.
No, you were close. You're just missing that one key part. So higher.
It was increase the frequency.
So an increase in the frequency increases the pitch, gives it a higher pitch. What if I lower the frequency?
A low pitch.
Everyone together?
Low pitch.
I only hear this side of the class. Right, you're fine once it gets here. Amplitude. What happens when we change the amplitude?
The amount of air molecules.
Well, how does it apply to sound? You have to, raise your amplitude. It increases the sound, right? It makes it, what, louder? Yeah, right? The sound is louder with the greater amplitude. And what if I lower the amplitude? Okay, very good. So, right. So what kind of wave is this? Is it, what kind of, there's two types of waves, right? What are the two types? Longitudinal and transverse, right? So what kind of wave is this? Alright, let me see a show of hands. Talk with your neighbors for a second. Talk with your neighbors for 30 seconds. What do you guys think? I'll try getting it. You can hit it too. It doesn't work as well. So what kind of wave is this? Let me see a show. Transversal, right?